In this video, we have the integral of 1 over secant of x minus tangent of x. So you could work with secant and tangent here if you can find an approach or a substitution here. It'd be nice if we had a secant squared in the numerator. Sometimes you can go the sine and cosine route, and we can easily do that because secant of x is the same thing as 1 over cosine of x. They're reciprocals. And we know tangent is the same thing as sine of x over cosine of x. And you're always allowed to multiply an integrand by 1 or add 0 to it, and it doesn't change the integrand. Well, the same thing here. I'm going to multiply the numerator by cosine of x and the denominator by cosine of x. Gives the integrand a different look, but they're still equal, whatever I get from here, because I'm multiplying by cosine x over cosine x, which is 1. So cosine x multiplied by 1 gives me cosine x. And the denominator, cosine x multiplying here, we'll cancel this one here. Cosine x multiplying this term here in the denominator, we'll cancel this one here. So we're going to have then cosine of x dx. That's what we have in the numerator. Denominator, this is going to go to 1 right here. Multiplying the tangent of x is going to go to cosine cancels. So I'll get 1 minus sine of x. And the easier substitution is, for me anyway, when you set u equal to the denominator and take the derivative, and you get what's in the numerator. So I let u equal to 1 minus sine of x. Then my du would be the derivative of 1 is 0. Derivative of sine is cosine, and of course I have the negative, so this will be minus cosine of x dx. And let's multiply by a negative here. So this becomes a positive here on the right side. And on the left side I get minus du. So this is going to equal to the integral cosine dx right here, cosine of x dx. That becomes that can be replaced by minus du. I'll put the minus sign in front here. This will be du. And then the 1 minus sine of x over here, that's your u. So we got u here. And again, anytime you have the integral du over u, that's always going to be the natural log of the absolute value of u. And always go back to the original variable. So in this case, u is 1 minus sine of x. So this would be 1 minus sine of x. And of course, you have this minus here still. So that's minus here plus the constant of integration. So the final answer then is minus natural log of the absolute value of 1 minus sine of x. Now this is your answer, and I always recommend just to practice your derivative to check your answer if you have time. Obviously you don't want to do this when you're taking a test because you have to complete the problems. But over here on the side, I'm going to take the derivative. Let's take the derivative of this expression here and show that it gives us the integrand. Take this out so we can see it clearly. So obviously you check, then is to compute the derivative of your answer, and it should give you the integrand. Now sometimes the check is more difficult than getting the answer for the integration. But in this particular case here, let's see, the derivative of the natural log is going to be whatever you have in there as your argument. Let's be 1 minus sine of x. That'll go in the denominator. And then it's the derivative of 1 minus sine of x. The derivative of 1 is 0. Derivative of sine is cosine. But I have the minus here. So that gives me a minus cosine of x. And then, of course, I had the negative to begin with there, so I have a negative over here. So those cancel out, and it gets a positive. So that's the derivative. Now we want to show that that gives you the integrand. So it's kind of reversing your steps here. We divide the numerator by cosine, and we get 1. Divide the denominator by cosine of x. So we're dividing here by cosine of x. And we have to do the same thing with the denominator. So obviously we know what we have to get. We're dividing here. So 1 divided by cosine of x, 1 over cosine, that's going to be secant of x. Secant and cosine of reciprocals. I got a minus there. And then sine of x over cosine of x, that's tangent of x. And that's your check. We get 1 over secant of x minus tangent of x, which is, of course, this integrand here. Thanks for watching. We'll see you next time.